All right, we are going to continue talking about functions and diving deeper into what they all mean, especially compared to real life situations. And today we're going to focus on graphs. And I like this statement right here. They provide a visual story. All right, so we're going to talk about increasing and decreasing functions, but we're going to talk a lot about what is the graph telling us. Okay, so it says graphs are useful tools in terms of representing data. Most of the time, people would rather look at a graph that gives you the information than read a big, thick paragraph, right? It highlights important facts surrounding the relationship between quantities. Again, that visual seeing story, telling us what's going on. The graph of a linear function is a line. We have talked about that. A linear function is a line. That's graph. The slope of the line can provide useful information about the functional relationship between two quantities. When we say between two quantities, there is some values that are on our x-axis. They're representing something. There's some values on our y-axis. They're also representing something. Okay, and so the line that the line that we put on the graph, that's a relationship between those two quantities. So a linear function who has a positive slope is said to be an increasing function. A graph who has a negative slope is said to be a decreasing function. So remember, we learned way before about slope, and what we said was slope is not a point on the line, or not a point on the graph. Slope is a number describing the line. It's telling us what it's doing. Is it going up? Is it going down? How steep is it? How fast is it going up? How fast is it going down? Here's kind of a new thought, though. It says a linear function whose graph has a zero slope is said to be a constant function. All right, so this is the one that's going to trip us up a little bit because we're used to saying constant being a number we're multiplying by. But now we're talking, again, we're switching from the equations we've been working on to functions. And a zero slope means it's staying constant. So it's not that we're looking for the constant, the number we're multiplying by when we before we're writing linear equations. We're talking about the line on our coordinate plane. Let's look at some examples that makes more sense. All right, it says read through each of the scenarios and choose the graph of the function that best matches the situation. And then we want to explain. So what we have here is we have 4 different scenarios and we have 4 different graphs. Okay, so let's read through our scenario. A bathtub is filled at a constant rate of 1.75 gallons. Oh, constant, right? That should be zero slope. We saw the word constant up here. No, okay. Step back for a second and let's think about this. It's being filled at a constant rate. Remember, rate of change, unit rate, slope, it's the number we're multiplying by. And you see the word per right here, right? Okay, we're going to take 1.75 gallons and we're going to multiply it by the number of minutes. All right, so we're filling it at a constant rate of 1.75 per minute. But then the next one said it's being drained at a constant rate of 2.5 gallons per minute. All right, so what's the difference between filling and gaining and drained? Sorry. Well, if it's being filled, don't you think it's increasing, right? If it's being drained, it's decreasing. That's going to be important. How about a bathtub just contains 2.5 gallons of water? Doesn't seem like anything's changing there. And a bathtub is filled at a constant rate, again filled, of 2.5 gallons per minute. Well, these two here seem like they're the exact same thing, with the exception of their rate. They have a different rate. All right, so let's see what we can figure out. Always, always, always pay attention to your labels. We have time in minutes down here, and that is going to be the y-axis represents how much water in gallons there are, okay? So if we look here, here's 0, 5, so at 0 minutes, there's 2.5 gallons. And at 2 minutes, I'm going to say about 2.5, right, from 0 to 5. And at 4 minutes, there's 2.5. And at 6 minutes, there's 2.5. So there's always 2.5. So is it being filled? Is it being drained? No. It just contains 2.5 gallons of water. So I'm going to say this is scenario C, and here's my explanation. The amount of water in the tub does not change. It remains, sorry, I'm writing big here, so I'm going to go outside the box. It remains constant at 2.5 gallons. That right there is why we have up here zero slope is said to be a constant function. Now, if you think back, zero slope was a horizontal line, right? Slope tells us how much is going up or down as we move from left to right, and this is moving 0 units up or down. So it's constant at 2.5. That's what that constant means. Okay, so now let's look at the other three. Okay, let's come back up to this one. Okay, so when I look at these bottom two here, the difference between these and these, well, remember, we always read graphs from left to right. This one's going down, this one's going up, and this one is going up. All right, so if I go back to my scenarios, excuse me. Oops, right here, yeah. This is being filled, this is being filled. So we kind of talked about how that's increasing. This one is being drained. So the amount of water in the tub is going to be decreasing for B here. So I'm going to say that this is scenario B, but I'm going to try to actually use the correct tool here. Scenario B, and my explanation is, well, the bathtub is being drained. So the amount of water is decreasing. Okay, look at this. At 0 minutes, because again, we're going to pay attention to our labels. At 0 minutes, there was 20 gallons of water. At 8 minutes, there's 0 gallons of water. That means it's being drained out. So that just leaves us with our two A and D here that are being filled. The only difference between these two is this one is being filled at 1.75 gallons per minute and this one is at 2.5 gallons per minute. I want you to think when we were working on which person has the greater rate. Which line is steeper? The steeper line has the greater slope, okay? And that's going to come into play here. If I look at both of these lines, notice they're both at 0, 0, okay? But at, let's say, 8 minutes, because I'm paying attention, I am like at 20 gallons, right? Here at 8 minutes, I am approximately, well, just below 15. I didn't draw my lines real great there, right? So which one has the greater rate? If I did 20 divided by 8, that slope, that rate would be 2.5, right? So since this line is steeper, all right, than this line, okay? This is at 10, it still hasn't hit 20, okay? This is steeper. That means its slope is greater. So we're going to put that graph with D here. Okay, we're going to say scenario D, and we'll say the bathtub. Sorry, guys. I'm right sloppy to begin with. Writing on my tablet here is not helping. The bathtub is being filled at a constant rate of 2.5 gallons per minute. Then I'm going to add a little something. It's a steeper line. It's the steeper line, right? Steeper line, greater greater slope, greater rate of change. Okay, which means, of course, this last one has to be A because it's the only one we have left. Okay, and we'll just say the bathtub is being filled, spelling it correctly, at, oh goodness, a constant rate of 1.75 gallons per minute. Okay, so as I try to spell here, that's the word minute, sorry. Okay, so again, our focus on this one is what is our line doing? What is our labels telling us? How are we able to read these visual stories to help us understand problems better?